Hi, everyone. So today we're going to do more solids, moving on from our curves and our surfaces, and then some subdivision surfaces, which is new in Rhino, but pre-existing in 3D Max and Maya and other softwares. And we're just going to learn a couple tools of how solids are dealt. So from the introduction lecture, you might remember that I said Rhino is a surface by default software, so that if I took a bite out of any sort of spherical shape in Rhino, that it will always be hollow on the inside, whereas SolidWorks, Creo, and other solid-based software perform more like an orange, where if you take a bite out of them, they actually have a solid material on the inside. So one of the ways that might appear as different or problematic is if I had a sphere and then made a bigger sphere with the same center point. In a solid-based software, I'd be able to subtract the smaller sphere from the big sphere and then use a cut plane, chop it in two, and open it up, and it would be kind of like an avocado without the sort of seed or the shell. But in Rhino, because it doesn't see the solids, that's just a surface that is not intersecting with another surface. Therefore, Rhino will just say in the command bar, Boolean split failed. Could not do that. The only way Rhino will deal with solids interacting with other solids is when their surfaces are actually intersecting with each other and touching. So if I did this small sphere and large sphere, and I did a Boolean subtraction, Boolean is called, the volume of the small sphere would cut away from the big sphere, and I would end up with this sort of Star Wars Death Star-like shape. But what's really happening from a Rhino perspective, because it only thinks in surfaces, is it is splitting the smaller surface, then chopping that off, then adding that to the big sphere, and then joining them together, and then making that as the complete shape. So when I was on about older versions of Rhino and older computers, that's why if you did too many Booleans, Rhino would crash, because it's just doing too much computing. But in solid-based software, they think natively in solids, and it's not so much of a problem. In Rhino, if there's a command split will think in surfaces, but the command Boolean split will think in solids. So depending on what command you use will be how Rhino responds and thinks whether it's meant to think as a surface or meant to simulate this sort of solid behavior. So if I take this sort of rectangular volume and I add a whole bunch of spheres along intersecting with the edge surface of the rectangular volume, and I do a Boolean difference, now I'll end up with this kind of like cheese-like shape where it has removed all of those spherical shapes and attached them to the rectangular shape, giving me this sort of cheese-like thing. And now that's now one object. So if I click that, that's one sort of solid object. If I exploded it, I would have the separate surfaces, but that's now a solid volume. If the order is important, of course, so generally you're going to select the volume to be cut first and then select the cutting objects. It will ask you to input them as a second step, which you read the command prompt and make sure you get the first and the second. If I did it in the reverse order, I would get the spheres or the rectangular volume subtracted from the spheres. So examples of where this appears in real world, which I always do architecture because it's what I know. Here's a building where you have these large buildings, I guess, built during modernism, where they had these really deep floor plans, and the sort of urban design was too big. And the general trend now is to have buildings that air and light can move through. So they're designing buildings where you're just subtracting the interior volumes from the larger volume, where this should really be 4 towers, but it's just made as a sort of overall singular structure, still trying to get the smaller distance from window to interior. So in this case, it's a cube with these sort of ellipsoid solids removed from it, and then just the contour command and 3D print. And this is a different one by HackadayU, where it's more of a sort of smooth, fluid surface, probably what we're going to learn later today, a subdivision surface. And it's just the cube subtract, or the interior volume subtracted from the larger volume. So when I open the software, we'll do some Boolean kind of subtraction. I'll show you how it works, but that's kind of it for Booleans. If I was to take several curves and they're slightly different, I can use the pipe command, which is a way of going from a curve to a solid, and it's going to ask you for a radius at either end of the pipe. So as long as I put the same radius, if I start with a straight curve, I will get a straight pipe. It works for curved pipes. If this line here is a polyline where it's joined, where this is separate polylines, and notice when you're using the pipe command, it performs differently if they are joined or not joined. So this kind of automatically sort of miter cuts them, and this just sort of leaves them open. So you might want to, in certain cases, rebuild the curve before doing the pipe command, which, so it's all joined and it's going to do a single pipe command. If I was to do a different radius, that would be sort of this tapered pipes, and it doesn't work that well on polylines. It just sort of makes 3 separate pipes. The problem, or one sort of problem for the last several editions of Rhino, was how do you do 3 pipes coming to an intersection? And you could sort of put them to a certain extent, but how do you make this 3 pipes kind of come together? And in NURBS curves, it's quite difficult. You sort of have to do a lot of intersecting and then trimming and then splitting, and that it doesn't even look that great. And it takes like 10-20 minutes just to do this intersection. So with subdivision curves that we're going to explore in more detail, but we can now use the multi-pipe command to select the 3 curves, which are NURBS curves, and it will just automatically make this sort of polygonal mesh shape that doesn't much neater. So this multi-pipe command is going to be useful when we start drawing the kettle that I mentioned last week. When typing in Rhino, SEL to select, which is another great way of, if you have a lot of information in the model, just select only curves or select open curves, only get open curves. This is a subdivision surface, not a NURBS polysurface. So select polysurface would not select this object, but select subdivision would select this object and not other objects in the model. So this is the kettle I'm going to draw, and hopefully you guys manage drawing it as well. It's a pour over kettle, so it's for having a very thin spout and pouring out the water very slowly. That's sort of the main thing. So the first thing I would do is I just made this in slides. Hopefully it's more easier to see the steps. So I'd sort of bring in the picture of the kettle, and I would just trace over with these lines. I wouldn't worry too much about trying to make the curves, because I'm going to fillet them afterwards. And because I want the pipe to overstep the curved area, I want this line to come over the curve, and I'll show you that in the 3D model. So first thing I would do is draw these as curves. Then I would do all my filleting of different amounts to kind of get the round parts. A big one here, another one here, another one here, another one here. So then into perspective view, I'm going to select this edge curve of the main thing and use the revolve command, the same as the chess piece, do a full 360 revolve. And then do the same thing with the top here, which is a thermometer in real life. It doesn't really matter for this. Then I can do my multi-pipe on this 3 different curves here. And I want it not to be capped because a capped multi-pipe will make it smooth. So I have to do the caps manually in NURBS. And see how it oversteps the interior of this sort of revolved shape. And I do the same thing here. I can just do a regular pipe there. And because this is separate curves, if they are not joined, these intersections won't work out properly. So it's very important that initial curve is joined. Then if I do a split on the handle, so the handle currently just overreaches the interior. If I do a split, it's going to change that surface into a NURBS poly surface. And you can see how complicated that intersection is. That's why we didn't want to do it manually. And that's just trimming to make that sort of, because that's not a perfect circle because it's sort of going around the curved edge. The next thing I want to do in modeling this kettle is this has a cut plane here. So if I went into 2D and did a cut plane, which any object, I just select cut plane, draw over it in a two-dimensional view, and it just makes a surface that perfectly overlaps everything that I've selected. Because if a cut plane doesn't cut entirely through a shape, it just says, Rhino just says, does not work, kind of like the Boolean problem. Just Rhino cannot cut if it doesn't finish the full cut. And that will trim this to be flat, which is how the kettle should look, and that gives a good pour, according to the coffee enthusiasts. And then I can offset surfaces, which makes them solid and gives them a thickness. If I wanted to 3D print the object or do something, they would want to have a thickness because as I mentioned in week 1, surfaces and curves in Rhino are a thickness of 0, so they have no thickness unless they are a closed shape or a closed poly surface. So now I've offset a thickness, and I've done this deliberately in the wrong order because now I have this problem at the top of the spout. And all surfaces in Rhino will have a normal, sort of a face and a back face. They have a front order and a back sort of face. That's important for rendering, which side is the inside, which side is the outside. Also, if you're extruding one way, the default way would be to go the normal direction. And when we open the software, I'll show you how to flip the normal and see what the normal is and how to control the normal. So now I need to get the cut plane again and trim that to be perfectly flat, which is now flat as a solid. And that's kind of the steps needed to draw this kettle. So, and there's it sort of in 3D view, and you can see it's got its thickness there. I'm not trying to make this for manufacturing, so there is some interior details inside here of a weld and sort of a screw, but I'm just going to worry about the sort of volume for this exercise, so we don't go into too much detail. And then I just thought I'd share one extra tool with you. I've never used this tool, but just to show you what a cage edit is, that is where you sort of select a bounding box around any volume. You select the amount of points you want. So in this case, I just did a 3x3 grid, and then I can deform this to anything. It's still NURBS curves. Depending on how it's constructed, it will stay together in its deformed shape, but it's a fully three-dimensional deformation of a solid shape. So with that, I'm going to jump into Rhino and show you how to draw the kettle. So the first thing we're going to do is load in our picture, which just any downloaded JPEG will work. And I'm going to do 0, 0, 0 to get the first corner. So I select it there. I don't really care about what scale this is because I'm not making it in real life. But if I was to, I'll just do 300 milliliter. Okay. So that's a scale. If I did have a proper scale or proper measurement in the kettle in my kitchen, I could do this more accurately. So then I want to rotate 3D to make sure the kettle is sort of vertical. I'm going to type layer to bring up the layers, and I want this change layer, and I'll put that on layer 1, and then I'm going to lock it. So that means it's not clickable, but still there in the background. So now, the layers, I double click front to sort of expand this view and draw some curves. So I'm really going to do a revolve in a minute. So I'm just interested in half the geometry. I don't need to go further than that. I do want to make sure that endpoint is selected. Just hover over and get that endpoint. Go past the curve. Then ortho is on, so I can't do the diagonal. F8 is the short for ortho, which depending if you're using a laptop, you might need the function key to be clicked, but I can just click it here on the screen from the bottom sort of snaps. And now I can do off the sort of horizontal and vertical, and that's fine for that one. And then this photo is kind of difficult to pick the bottom point and what else to do there. Now I want ortho to be on again because I want a perfectly horizontal line. So that's those curves. This top bit is, I'm just going to get near. So now I know that those two lines are perfectly aligned. And so for the pipe command, I want the middle of these shapes. And again, I'm going to have to turn ortho off to get that one. And that's going for that. And in this case, I want to overstep this one as well. Okay, so that's the geometry I need, which if I had scaled that properly, it would be perfect. So I can do the light bulb to turn off layer 1, which turns off my, I'm just going to guess a lot of these filleted shapes rather than do it from the So the amount of fillet will directly depend on what scale your model is. And so trim command, just get rid of that one, and then a little fillet. Yeah. And another trim to get rid of this. And this time I need this to overlap, which ortho is not on, so it's not dragging horizontally. So F8 to turn ortho on, and that needs to step over. And then some fillets over here too. Probably a bit big, but it's fine. So now I can drag over this and type join. So now that's 5 curves. You can see, read it from the command line, 5 curves joined into one open curve. And if I select that, it selects as one. I similarly want that curve, the filleted curve, that curve, the filleted curve there, and filleted curve. And I want to join them. So it says 6 curves joined into one, and now they select as one. And then this whole top thing, join that as well. So it's 3 curves joined into one. So now they are, each one of those curves is just one joined object. And that can stay the way it is. And I can now go into a 3D view. So the first thing I want to do is select that curve and type revolve. And I need to give it the central axis, which is just click this point and this point at the bottom. And I can just type 360 rather than drag it around. And it should work. So I type 360 and there we go. And if I do this one, if I right click, I get the same command as I used previously, which can get me going pretty fast. And I need a resolve axis. So I click that point. If I didn't have, I mean, I could click that center point, but I could also just control click and then just click anywhere, and that gives it that perfect thing. Start point, and if I drag it around, that's how the dragging works. So I need to drag it all the way and then left click when it's done. Or then right click when it's done, sorry. And that gives that shape. So now I'm going to do my multi-pipe, and I'm going to type multi-pipe, and it's going to say select the curves. So I want this curve, this curve, this curve, and enter or right click, and set the pipe radius. I'm just going to put it at 15, see if that works. Cap ends, I'll just turn them on to show you what that looks like. And then I can type 0 or 1 here. So the problem with the cap ends being on is it's going to smooth them, which is not what I'm looking for. So I want the cap to be off, and also probably a smaller radius. So let's try 8, cap off. So I click on these options, and then this can be smooth or not smooth by typing 0 or 1. I'm going to, let's say if I put 0 first, it basically makes it too loose here, which is not what I'm looking for. So I can just redo that and type 1 for not smooth. And that's the shape I'm kind of looking for. So these are now open because I didn't want to cap them with a subdivision. I want to cap them with a NURBS curve. So I can type DUP and then edge or border, which is duplicate, which is how I go from any surface to a curve. So I basically want this curve, which if I double click, it selects the whole circle. And you can see the surface, holding down shift to get both of them. So now they are curves, they're probably separate. So I'm gonna, while they're still selected, type join. Let me select them again. Or maybe they are selected. Yeah, I said they're already done. So now I can take the 2 curves that I duplicated that are sort of at this angle and type planar surface, which should fill them in. So that fills them in fine. If I joined the NURBS planar surfaces to the subdivision, it would just become a subdivision, or sorry, become a NURBS surface. It would sort of convert it automatically. But I want to split this. If I had of go into a different view, and do zoom all selected. If I had of gone right to the edge, then when I did the multi-pipe would stop at this point, and I'd be missing this tiny amount. So that's why I kind of overstepped it so that it would get that thing. And now basically I want to do a split. I'm not going to do a Boolean split because they're still surfaces. So select object to be split, which is the subdivision. And then select the cutting objects, which I want that to be the revolved kind of kettle shape. And now I can select this part, which is I don't need. Probably not necessary for modeling, but if I wanted to, I could select the kettle shape and right click just to repeat the last command, which is split, and split the kettle with this poly surface, because it's now poly surface, and right click to press enter. And that's just going to remove that circle there. It's going to like cut the hole. So same thing on the other side. We've already joined this, so it should pipe as a single pipe. And it's a much smaller spout. So we can just do pipe, which is going to be a NURBS command. And let's just try 4. So if I type what's in the brackets here is what it's currently set to, 15. I don't want 15. So if I type 4 at the end and 4 at the other end, I get, yeah, that's about right. So I guess I didn't make that far enough. So I can do extend. And if you do extend, the regular extend, it asks for what you want it to extend to, but I just want it to extend anywhere, which extend dynamic is just a better extend. So I can then select the curve and then just drag it past. And then we can do our pipe again for enter. And now we have that, and it goes, that's perfect. And I want to select this and type split, select cutting object, and that's going to remove this little part. And then if water was to move, I want the other part coming out of here as well. So type split, object to be split, enter, cutting object, it's going to make the cut, enter, and that should, so they're like separate surfaces, but I want to delete the circle because I don't want the circle. And then now that's like perfectly fitting. And it's those kind of things, by the way, that if you didn't notice these microscopic openings and you went to 3D print, that it just wouldn't work because an open solid is not a solid, and a 3D printer just can't see it. So I can now select the sort of spout, and I want to type cut plane, which is going to create a surface which perfectly cuts, and I want to basically chop off from this corner. So I'm going to select this corner and then just select there, and it creates the cut plane all the way to cover this in case, see there's another one, it covers the whole thing. And I can use the split command to, so there's the poly surface, split, select the cut plane, and then I don't need the cut plane anymore, and I don't need this top part. So there is our shape. And then now, if we want to make this thickness, the last command, offset surface. So I type offset surface. I select the shape, and it asks me, so here's the normal direction. So it currently wants to come outward. I actually want it to go inward. So it says select object to flip direction. So if I left click it, it goes inward. And if I left click it, it goes outward. So I can choose one. So I want it to go inward, and I right click to say go inward. And it's currently set a distance of 0.3. That's probably fine for this. So it's ever so slightly thick. Let's just do a bigger thickness so it shows better. Let's just do 3. Yeah, so there's a very thick wall to the kettle, but it's fine. And if I do the same thing for the spout, so again, it's wants to go outward, left click to go inward. And oh, let me just do it thinner. Let's just do one. And there's that problem at the top that I kind of mentioned. So I need another cut plane. But when I chop this time, I want to chop from the lowest possible point, which is there. My ortho is on, so it's horizontal. So that's my perfect chopping plane. And I'll show you what split does in this case, just to show you the difference between the two. So if I type split and then use the cutting plane, and then I delete the geometry here, this is now open, like it's just, which I could select those two circles and do a planar surface, but it's just extra steps. The smarter thing to do is when doing the split, to do Boolean split, so it starts to think in solids, not in surfaces, then select the cut plane. And now I can delete that, and that should be a solid cut. So if I go to my rendered view, there's my spout. And there's my debug. So it'll probably take you too long to draw that. So maybe we'll just continue on to subdivisions, and then I'll just stay around for questions at the end. We'll do it in the normal format of an hour, and then you start drawing and ask questions, and I'll stick around. But that's the teapot pretty much done, or sorry, pour over kettle done. And in real life, it has a few little extra complexities inside of there, and this is a thermometer, so it has a sort of metal part that goes down into the kettle. But from the external perspective, it's fine. So if I'm just going to delete that because I don't need it, but you guys might want to save it if you want to keep it.
James Brent has a question too.
Yeah, let's. Do you want to read it or?
Yeah, he says, if you're trying to fillet a joined polyline, is there a way to select each section of a polyline?
If you're trying to fillet a joined polyline. Oh yeah, so I'll just show you. If I'm going to fillet something, maybe I went ahead with the left clicks a little too fast. But if they were separate, I would just click the first curve and click the second curve. They are one object, but I still click here and it selects the whole thing, and then I click here, and it just thinks of them as two separate things. So even in a closed polyline or a sort of closed curve, I can still go in for corners and just select the left side and the right side, or the top side and bottom side, and it will fillet that. I think that's what the question is.
Yeah, he says, okay, trying again, couldn't get that to work.
One reason why a fillet, or the main reason a fillet would not work, is when you fillet, you're going to need a radius to fillet. And if you imagine something being 10 centimeters or 100 millimeters by 100 millimeters, and you come in with a fillet that's 10 meters, it's just going to say, will not fillet. If you come in with a fillet that's too small, you might not be able to see it. It would work, but you wouldn't be able to see it. It would still just look like a corner. So try around with some radiuses to make sure and know what scale you're working in. I would imagine that's probably the issue, but do let me know. I'm going to jump into, is there any other questions, or is that it?
Francis, thanks.
Yeah, okay. So we're going to jump back into some slides, and the second part of this week's lesson is in subdivision surfaces. So this by many people is considered harder. Certainly people I know in the architecture world would consider it harder. Everyone in animation and virtual reality and that's the default they learn is sort of polygonal modeling. I'll show you when we get into the software, but you start at a different point. In NURBS curves, you usually start with curves and then you mathematically construct those curves very precisely, and then you bring those curves into surfaces and then poly surfaces. So you start at the sort of basics and you sort of build the model sort of through addition. In subdivision, a lot of the time you start with a volume and you deform the volume almost like sculpture, where sort of your volume is clay and you're deforming it. And one of the ways you control it is you turn on this gumball mode. And I'll show you what all these things do, but it's just one way of controlling, more useful. Some people have it on all the time. I find it useful for subdivision, kind of annoying for NURBS, but personal preferences, I guess. So there's some new terminology when it comes to subdivisions. So every subdivision has these sort of two views. In Rhino, if you click the tab button, you go back to the original geometry, which is on the left, and then the sort of simulated smooth geometry, which is on the right. But this is, I've just made this in the slideshow, tab off on the left and tab on the right. But this is the same shape. It's the same object. And so if I select the top corner as a vertex or vertice, that you see that that's that top point there, and that's that top point there. They're the same point. And the terminology is kind of important, that you can sort of, when it comes to subdivisions, you select the vertices, which are kind of like points, or you select the edges, which are just edges here, which you see the yellow selection on both sides, same edge on both. You could select an edge ring, which would select all these edges. And the reason you do that is when you have the edge ring, you could then scale it or rotate it, and it would start to deform that smooth surface. So that's called an edge ring when they're, I guess, parallel to each other. An edge loop, when it's just one sort of continuous ring. They are all separate edges to be selected, but if you select an edge loop, it will select the whole edge loop. Edge loop on the top side, you can see only actually selects one edge of the cube. It doesn't select the whole top surface because it doesn't really know which one's which. Then we have faces, and you can select a face and extrude a face or do what you want with a face. But so we have vertexes, edges, and faces. A face loop will be select all the faces in a loop around the object. If we were to extrude, which the command is extrude subdivision, extrude curve will only work on curves, extrude surface will only work on surfaces, extrude subdivision will only work on subdivisions. So extrude subdivision, and we selected a face, it would extrude the face, but it would add new surfaces. So that's a new surface that wasn't there before. That's a new face. That's a new face. That's a new face behind, and that's a new face behind as well. If I was to select the face and I would just move it, I would just drag it upward, that would be a very different command to extruding it, because when I extrude it, I get these 4 new faces that weren't in the model previously. So, and I get new edge loops because I have edges there. If I was to move it, I wouldn't have that edge and that edge loop basically where the mouse is there. So that's an extrude subdivision, extrude face. I can then subdivide any of the faces. So the default will be to subdivide any face into 4, which creates new faces. And then I select new vertices, new edges, new faces. And as I mentioned on the introduction lecture, if you were doing a face, you just continually subdivide the faces into further subdivisions to add detail. So you might start with a sphere, deform it into kind of a head shape, then subdivide the faces towards the front and begin to develop the nose, and then further subdivide them and add the nostrils, and then further subdivide them. And you just keep subdividing to add detail. So the back of the head would have very little amount of geometry. but the front of the shape would have all these subdivisions and it would be quite complicated. You can delete the face. If you see, I deleted on this side, and this is the only time that they're actually different. I deleted on just so they face each other. And I can use the bridge command, which would, these would currently select, if they were two separate subdivisions, select as two separate objects, but the bridge command would join them together and add new face, new face, new face, new edges, and make it into one subdivision object. So now all of these faces, these edges, is sort of one object, and we have extra subdivisions on each of these sides. And this is what that would look like in the smooth view. And I just thought I'd show you a project unbuilt, a Guggenheim Museum in Guadalajara in Mexico, unbuilt. But I would imagine this is somewhat the kind of moves they would have done. This was done before Rhino had subdivisions. So it was probably done in Maya or Max by a New York firm called Asymptote. And this is it from the top view. A lot of them just kind of, Guggenheim asked for designers to create projects that they were never going to build, but it was, I don't know, to attract attention to a city or funding to a city, or it's kind of, anyway, that's kind of a cool unbuilt project. So this is a project that I did where I did this. My dad said he liked these old tractors, some tractor that was a big milestone for moving ahead the world of tractors. When he was a kid, he grew up on a farm, and he said he wanted the tractor, like, which would be a collector's item, some tractor from the 1940s by Harry Ferguson, which is the Ferguson in Massey Ferguson. And so I made him for Father's Day or birthday, I can't remember which, I made him the stool, which is kind of this iconic seat shape on that tractor. And I drew it in 3D Max, imported it into Rhino, which would have been a subdivision surface, brought it into a NURBS surface, and then sort of subdivided it, laid it out, and CNC'd it. And there was another version, which I couldn't find, which was thinner pieces of wood and more of a grid shape. But there's that. So the top shape in this is created through subdivision geometry, and then the contouring command that we did last week. And it sort of has that sort of tractor stool seat. And now I'm going to try, this is my attempt. I'm not very good at subdivision drawing. It's a very different skill set. But I tried to draw a cat since I got cats in the last week or two, kittens. And I'm going to jump into software and show you kind of how to draw in subdivisions. So this is stuff from previously. I'm just going to Control A to select all and press delete so that we're starting from scratch. So on this menu here, standard C-plane set view display, select viewport layout, visibility, transform, curve tools, surface tools, solid tools, subdivision tools. That's what I'm looking for, and it goes on. So this changes my icons on the left-hand panel. So my explode and join are gone and different. And all of these tools on the top are for subdivision shapes only. I'm going to start with a box, or actually, let me drag in a picture of a cat so I can from what I understand, professional modelers would take photos of things in real life, drag them in as pictures, and do this kind of tracing over process, the same as I'm going to do here. I didn't measure that because I don't really care what dimensions this is. So I'm going to rotate 3D and rotate my picture up to be vertical. I'm then going to type layer, change layer, change this to layer 1, which is off, turn on. Unlock the layer, delete my kettle, which I don't need. And then I can block that. If you remember from last time, that the layers is this red, white, blue slice of pie. Properties is here. I could have gone properties and changed the layer by selecting the object. I have it locked now, but selecting the object and then layer and change the layer manually there. So I'm going to lock that layer and I'm just going to get rid of layers. Normally, I'd actually have layers over here on this part of the screen. I'm just clearing up screen space. Okay, so I'm going to start by drawing create sub D box, which if I was to just type it is sub D box. And I'm going to right click to get out of here. So I've just drawn any size box. So select the box, M enter or move enter, and just drag it up here. So it's kind of snapping where I don't want it to snap. So I'm going to turn off some of these. I'm going to turn off ortho. And I'm just going to turn off OSnap for a while because I just want to move this here. And I'm basically trying to move this solid shape to roughly where the sort of main body of the cat is. I'm just going to move it a little bit away from the cat. Okay, so the key to working in subdivision is we're going to type selection menu, or selection filter, sorry. And this selection filter can work as a tool that you can use in any part of Rhino, but it is essential for subdivisions. You almost can't work without it. And you need to click this sub objects. It's kind of grayed out. Click the sub objects from the bottom. And that allows us to say only select vertices, only select edges, only select faces, or polysurfaces. These are all on when you start, and you just sort of deselect them all. And now I can sort of only select a face or turn that off and turn curves on and only select a curve. And that's because there's so much geometry going on. I'm going to basically flick these on and off to control what I'm doing. So I'm going to start only control the faces and select shift, hold down shift to select two and select this sort of back part. And just to show you tab on, tab off. So tab off, I get this, which is the true geometry, and then the smooth geometry. So that's just tab on, tab off. In other softwares, that's sometimes known as a modifier, turbo smooth, same thing. So from the tools up here, I find them kind of a little bit confusing, but this one here is subdivide sub D, requiring a left click. I could just type subdivide, but I can type that. And you can see that it has turned each one of the ones that I had into, or each face into 4 new faces. And if I get this, there you go. So just to show you the gumball, so where the grid snap thing is, if I turn gumball on the bottom, here's my gumball looking shape. And if I select the blue arrow and I just drag it, it's going to drag and lock to the z-axis, and the green one is going to drag it along that one. Okay, so first thing is I can right click on gumball and I can set the thing to be on the world view, which is the XYZ of the main model, or the object, which is sort of based on the normal of the surface. So that means that it will line up, the gumball will reset to the normal, change at sort of really weird angles. Mostly I want to align to the object, but I can align to the world. So now that's back to proper there. So if I was to just drag that with the blue arrow, that just moves up. If I'm to use this little kind of curved arc, That's to rotate, which ortho is currently on, so it's rotating a full 90 degrees. But if I lock to blue, there, it's going to rotate that. And you can kind of see if I tab off what's happening there. I'm just going to undo that. And these little squares is to scale it. So that's going to scale it along the blue axis, or the green axis would stretch. So see, it's going to scale it. So I can do all of the scale, move, rotate in each of the three axes using this gumball thing here. But I want new geometry. So I'm going to select two faces and try extrude subdivision. Attempt extrude curve, extrude sub D. Enter, and then direction Z axis, and type these two again, right click and extrude another time. And we start to have a tail. And then we basically want to select either faces or let's do it backwards. Basically drag them and kind of look at this front view over here. And if I need a kind of curve, I need to add more geometry, so I can do that by extruding. And then another thing I need to know how to do is to insert an edge loop or an edge ring. So I can select the edge loop, press enter, and then it just adds another loop there, which increases the amount of polygons. And if I, this one's slide edge loop. So if I select one edge and then I hold down shift to select a second edge, but I double click it, it should get the whole edge. And then that can sort of just move it. It's another way to do it. If I turn on my selection filter, curves edges on, surfaces off, select this edge, now I can start to move, basically move the edges and line them up to the diagram. So there's the shift select, that edge there. And I basically just go through the whole time, turning edges, surfaces off, selecting things and dragging them to kind of meet the background. So there's kind of, and I would do basically the same with the feet because I'm going to run out of time, but so I would select these surfaces, do a subdivide on those surfaces that takes four faces, turns them into 16, select these sort of corner ones and type extrude subdivision. And then I can kind of drag that one forward and drag this one backward. And it's sort of very different from this idea of just dragging things as opposed to mathematically sort of speaking in numbers. But if I did want to do numbers using the gumball, if I left click any of these things, it just asks me for a dimension. So I could do somewhat accurate that way. And subdivision modeling takes in my opinion. Well, you kind of do these very precise objects, but it does take a lot of time. So another command that's quite important is creasing. And if I type crease, and it says select mesh or subdivide edges, and I select this leg, and then I just type enter, it sort of says that that is sort of flat. Don't include that into your smooth, into your sort of formula for just smoothing everything together. In more advanced subdivision software, you, rather than just crease being on or off, you can set it as 90%, 80%, and you can do really nice kind of curved edges. But in as far as I can tell, in Rhino, it's either on or off. So now I basically do this, just keep doing the same thing, basically. Extrude this, change direction to x-axis, this way, and then select these two, right click and direction z-axis, and I'd go up, and then I'd move these in. If I select a face on that side and then select a face on that side, and I do a scale inward, that sort of does them kind of together, because the gumball is centered on the geometry, the selected geometry, so it sort of brings them in kind of nicely. And extrude again, and change the direction to X. And I guess this is looking a little bit more dog-like currently. But if I basically select all these edges, select these points, and match them to this sort of background geometry, then I would end up with that. So I'm going to do the what chefs do, and say, here's one I prepared earlier. And that. And it's not bad. You can also, when you select something, just straight out click, like if delete. So I could delete that and just create a big hole. I could delete the curve and see if it smooths it in the way that I want. A lot of the time that does create problems down the line with surfaces, but sometimes it's necessary. And that's kind of a cat-like shape. And basically, if you keep subdividing those faces, you just keep adding more detail so that you're doing eyelids and tongues and teeth. But you just kind of, you start with the box and you just subdivide, go more detail. So that's the beginning to subdivision modeling. I think drawing a cat is probably quite ambitious. But drawing the thing we covered in this kind of shape is probably doable. Just sort of doing a bridge, deleting a face, trying to select faces, trying to select edges, drag them around, move them, rotate them, doing that. If you can draw a cat or an animal of your choice or whatever of your choice, do it. So that's probably it for the instructional part of this lecture. So if people want to start drawing and ask questions, and any questions you can think of, just ask. I'll be here.